Hi guys, welcome back to ECChem channel for another important and interesting discussion today. Let us discuss in today's lesson some common and frequently appearing reactions and questions related to benzene molecules because it's a really interesting and important topic in A2 chemistry. First of all, remember that the reaction mechanism shown by benzene is, don't forget, electrophilic substitution. Electrophilic substitution is a reaction mechanism shown by benzene. First of all, we will try to discuss some common reactions of benzene, starting with the benzene molecule, and we will talk about 5 or 6 really important basic reactions. Now, to start with, we can change benzene molecule to nitrobenzene. You can see a nitonium part has been attached to benzene ring. We can do this work in the laboratory. If you react with concentrated nitric acid, remember concentrated word must be there. Concentrated sulfuric acid, both must be concentrated, and the temperature should be clearly mentioned 50 to 55 degrees Celsius. And afterwards, we can convert benzene into another compound, chlorobenzene. One chlorine atom has been attached to benzene ring. This addition of chlorine into benzene ring can be conveniently done by reacting chlorine gas, which is a reactant, with aluminum chloride. Aluminum chloride is a catalyst in this reaction. And let's see another reaction. We can change benzene to bromobenzene, similar to the earlier reaction where a chlorine atom has been attached to the benzene ring. This time there's a bromine atom. We can conveniently attach this bromine atom into the benzene ring by reacting bromine reactant with anhydrous iron 3 bromide, FeBr3. If you want, we can write aluminum chloride also for that, but I'm not going to write it over here. And afterwards, there's another reaction, which is methyl benzene. See, in the methyl benzene, what has happened is an alkyl group has been attached to benzene ring. Not only CH3 group, we can attach any alkyl group, maybe CH2, CH3, maybe CH2, CH2, CH3. Likewise, any group can be attached. And this addition of CH3 or any alkyl group is, we call it a Friedel-Crafts type of reaction. For that, the reagent we are using is CH3Cl. Now, if you want to attach an ethyl group, that means CH3CH2 group, then we have to use CH3CH2Cl. Likewise, only the chlorine atom is going to be different. And we'll look at another reaction. Okay, benzene has gone to phenylethanol. It's a ketone here, phenylethanol. This reaction is called acylation. Earlier, addition of CH3 is alkylation, addition of alkyl group. Now here, we have added an acyl part to benzene ring to make it phenylethanol. Now, acyl means carbon double bond oxygen with an alkyl group attached to it is called a phenylethanol. To do this work, also, we have to use ClCOCH3. You have to have aluminum chloride, and heat is also needed. I have not given heat for chlorine addition, bromine addition, CH3 addition, but here, heat is also needed. Now, these are basically some of the most important reactions in which we try to insert a particle into, or a group of atoms into the benzene. Remember, these are not addition reactions, these are substitution reactions. So substitution reactions occur on the benzene ring. And afterwards, we will see not only these reactions where you can see a simple group getting, or atom getting into a benzene molecule. There are reactions where Compounds of benzene also reacted further. We can take one example from nitrobenzene. Nitrobenzene can be changed to something called phenylamine. What is happening in nitrobenzene phenylamine conversion? Here we have two oxygen atoms in the NO2 part, and it has gone to NH2. The two oxygen atoms have been removed, which is a reduction, and two hydrogen have come in, it is also a reduction. So this nitrobenzene converting to phenylamine is a reduction reaction. We can do this reduction reaction by heating with tin and concentrated HCl. When you react nitrobenzene with tin and concentrated HCl, heat has to be provided. We can get phenylamine. Now, phenylamine can react again to produce another important ion, which is called phenyldiazonium ion. This phenyldiazonium ion is really important in the industry because it is used to react with phenol to make something called azodye. Azodye means nitrogen containing dyes. We can do this phenylamine to phenyldiazonium ion conversion by reacting phenylamine with dilute HCl and NaNO2, sodium nitrite. Temperature has to be specified 0 to 10 degrees Celsius. Temperature should be less than 10. Why less than 10? If you increase the temperature, then this phenyldiazonium ion is going to be unstable. So we have to maintain this temperature. Shall we look at another reaction of benzene compound? We go to methyl benzene. See what happens to methyl benzene first. This CH3 in methyl benzene has been changed to COOH. This is carboxylic acid. Alkyl group has gone to carboxylic acid. This is called an oxidation reaction. This oxidation reaction can be done, in other words, side chain. Now here CH3 has gone to COOH. Not only CH3, any alkyl group in our syllabus, maybe ethyl group or a propyl group, whatever it is, simply goes to benzoic acid where there's a carboxylic acid attached to benzene ring. This can be done pretty easily if you heat. I have given heat under reflux. Methyl benzene or any alkyl benzene has to be heated under reflux with alkaline potassium permanganate. OH minus is written, comma, Km. Initially, we had to add probably sodium hydroxide and KMnO4 and heat under reflux. Afterwards, we had to add some dilute sulfuric acid. You get benzoic acid. If we don't add dilute sulfuric acid, then we don't get the benzoic acid. If we add sodium hydroxide to this reaction to make it alkaline, then we will have a sodium salt of benzoic acid. To remove that sodium part, we add dilute sulfuric acid. Afterwards, there's another reaction where benzoic acid is going to produce a really important, very, very highly reactive substance. And that substance is called benzoyl chloride. Benzoyl chloride has this COCl part. A compound having COCl is called an acid chloride or acyl chloride. So benzoic acid has gone to benzoyl chloride, very reactive substance. It can be done by adding PCl3 and heat. If you add PCl3, you know, in the AS lessons we have learned, with PCl3 always we have to have heat. Or else we can use PCl5 also. Heat is not needed for PCl5. Or else we can use thionyl chloride, COCl2 as well. Okay, afterwards we'll see in this reaction scheme, there are different types of reaction mechanisms or reaction types involved. The first thing I want to talk about is electrophilic substitution. I told at the beginning also, electrophilic substitution reactions are happening when a group gets added into benzene. You can see there are 5 reactions where electrophilic substitution reactions happening. I have ticked them in red. Can you see them? These are all electrophilic substitution reactions. And we can find another reaction, side chain oxidation. I explained to you. Methyl benzene going to benzoic acid is a side chain oxidation. The yellow tick is there for that. And I'm going to introduce another reaction here. This is reduction. Of course, I have discussed about this earlier also. Reduction happens over here. When nitrobenzene goes to phenylamine, it's the reduction happening. There's a white tick for that. Afterwards, we will go to reactions of already substituted benzene rings. What's the meaning of it? In this, you can see here reactions happening on benzene molecule. Benzene molecule doesn't have anything attached to it, just a free molecule. When you talk about these free radical electrophilic substitution reactions, when you talk about electrophilic substitution reaction, the addition of the group to the benzene ring can happen at any carbon atom because all the carbon atoms in this benzene ring are identical. So reaction can happen anywhere. Now here I'm going to talk about reactions of already substituted benzene ring. It is something like this. Here, phenol molecule. Phenol molecule has a benzene ring with an OH attached to it. So this is an already substituted molecule. What will happen to this reaction? I'm going to talk about chlorination. If you react phenol with chlorinating agents, you get a molecule. See, I have numbered carbon atoms in the benzene ring, starting with carbon number 1 for the carbon which is attached to OH. We have carbon number 2 next. Chlorine has been attached to that, and it is called 2-chlorophenol. Not only that, there's another compound, and that is called 4-chlorophenol, where the chlorine has been attached to 4th carbon. So likewise, when you react phenol with chlorinating substances, we get 2-chlorophenol and 4-chlorophenol. I'll take another example. This time we have phenylamine. If you allow phenylamine also to undergo chlorination, you can get a similar product. See, 2-chlorophenylamine. Phenylamine goes to 2-chlorophenylamine, and also it also will give 4-chlorophenylamine also. There's something interesting happening here. When phenol and phenylamine react with chlorinated substances, the chlorine atom goes in the benzene ring either to the 2nd carbon or 4th carbon. See, in the second example also, chlorine has come to 2nd carbon and in the 2nd one to the 4th carbon. So likewise, you get a product mixture in these reactions. But chlorobenzene, if you do chlorination on chlorobenzene, you get 1,4-dichloro. I have made a small change over here. In the first 2, I talked about addition of chlorine to the 2nd carbon. So first one is 2-chlorophenol, 2nd one is 2-chlorophenylamine. So I have taken that 2 to the right-hand side in this 3rd example, where how is it 1,2-dichlorobenzene? Because only 1 chlorine is attached. To that chlorine containing molecule, another chlorine gets attached on the 2nd carbon. You can see that on the right-hand side. And I said I switched the sides. On the left-hand side, we have 1,4-dichlorobenzene. What is happening in these reactions? Chlorine is getting added into the 2nd carbon and 4th carbon. Why? Because it's a special property of OH, NH2, and chlorine. We can do all these reactions by using aluminum chloride and chlorine chlorinating agent. Before we go any further, we'll discuss about one more example, methyl benzene. When methyl benzene is reacted, also we get 1-chloromethyl benzene. This should be 2-chloromethyl benzene. This is 2-chloromethyl benzene. You can see 2. So this should be changed to 2-chloromethylbenzene. And the other one is 4-chloromethylbenzene. So in all these 4 examples, the chlorine are going to get attached to second carbon, making 2 chlorocompounds, or chlorine goes to fourth carbon, making 4 chlorocompounds. Remember in the last one, there's no 1-chloromethyl, it should be 2-chloromethyl, because you can see the green chlorine attached to 2. And how can you do this reaction? I have given over here chlorine, aluminum chloride, and heat. By doing this reaction, under these conditions, we can get a mixture of compounds. Now, again, I'm telling, in all these reactions, the newly added chlorine has gone to what carbon atoms? Carbon atoms 2 and 4 in the benzene ring. So we have a few more things to learn about this. We'll read this on the right-hand side of the screen. When groups such as OH, in the first component I have OH, NH2, Cl, and alkyl groups are attached to benzene ring, further reactions are promoted at second and fourth carbon atoms in the ring. Hence, these groups are called 2,4 directors. It means the further reactions are promoted at the second and fourth positions in the benzene ring. How is it happening? It is because, benzene reactions happens always due to an electrophile coming into benzene ring, because benzene ring is rich in electrons. Something mostly having a positive charge needs electrons. They are called electrophiles. These electrophiles always come to the benzene ring because of the negative charge. Now, why when we have OH, NH2, and Cl and any alkyl group, the reaction happen on the second and fourth place? It is because they activate, what are going to activate? This OH, NH2, Cl, alkyl group. Likewise, they activate second and fourth carbon atoms by donating electrons to the ring and by specifically making those carbon atoms rich in electrons. Remember, this OH, NH2, Cl, and CH2, they can activate the second and fourth places in the benzene ring. So, an electrophile can easily get attracted to these places. So the reaction happens in this manner. But how is it possible for these groups to activate the benzene ring specifically in the second and fourth place? See, you see where the reaction happens in the second and fourth place. It's because they are ring activators, and they usually have lone pairs of electrons on the atoms, which is directly attached to the benzene ring. You can see on the left-hand side of the screen, first on phenol, the oxygen has 2 lone pairs of electrons. Phenylamine has, below that, 1 lone pair of electron on nitrogen atom. Chlorobenzene has lone pairs of electrons on chlorine again. That is a speciality. So what happens when we have, there's another electron pair, I will add that also. When we have electron pairs, lone pairs of electrons on the atom directly attached to benzene ring, these electrons can delocalize in the benzene ring, and particularly on the second place and fourth place, electron configuration, electron concentration will increase. We see there's another electron pair to be added into chlorine in chlorobenzene. That's it. I think this idea is very clear. Now, similar to this, we will talk about another reaction. Still, we are in the reactions of already substituted benzene ring. This time we have a benzaldehyde, an aldehyde, benzaldehyde. If benzaldehyde undergoes chlorination, we'll see what happens. Where has the chlorine gone? Chlorine gone to third chlorine. Do you remember what was in the earlier question? In the earlier page, we saw addition happening on the second place and fourth place because they are electron donors. They can activate specifically second and fourth places. Now, likewise, in this one, we have phenyl benzaldehyde. This benzaldehyde, if reacted with chlorinating substance, we get the chlorine to the third carbon. Now this is 3-chlorobenzaldehyde. On the third position on the benzene ring, we have chlorine, so 3-chlorobenzaldehyde. We can talk about a similar thing, nitrobenzene. Nitrobenzene also is able to react with a chlorinating substance, and that also produces 3-chloronitrobenzene. 3-chloronitrobenzene. Do we have another example? Yes, we have phenylethanol. Phenylethanol is also going to react in the same manner, giving 3-chloro-phenylethanol. There are no two compounds, only one compound is there producing these reactions. There's a clear difference, okay? Now, fourth example is benzoic acid. There's carboxylic acid directly attached to benzene ring. When benzoic acid is reacted, again we get 3-chlorobenzoic acid. Okay. Now, what's special about this? Why these compounds are going to promote reaction only at the third position? There can be reasons for that. When groups such as CHO means aldehyde group, NO2 group, COCH3, this is a ketone group, and a carboxylic acid group are attached to the benzene ring, then what happens? Further reactions are promoted at the third carbon atom of the ring. We'll see another one. So these compounds are called 3-directors. Why? Earlier, 2,4-directors are activating the carbon number 2 and 4 by giving high electron concentration to the second and fourth place. But here, these 3-directors, they activate the third carbon atom by withdrawing electrons selectively from the second and fourth carbon, thereby activating the third carbon atom. Do you get it? These molecules are going to pull electrons away from third and fourth carbon atom. So electrophiles cannot go to second and fourth carbon atom. So only possibility is they can go to third carbon atom. That's the difference between these reactions and the reactions we discussed earlier. Now, these are called ring deactivators also. If there's a substance which gives electrons to the benzene ring, they are activators. If electrons are withdrawn away from the benzene ring, they are called deactivators. All these deactivators have a special property. What is the special property? The atom which is attached to the benzene ring in these groups is attached to a highly electronegative electron withdrawing atom. See on the left-hand side. Okay, I highlighted carbon double bond oxygen, nitrogen double bond oxygen, carbon double bond oxygen, carbon double bond oxygen. Here what happens is the oxygen is attracting electrons away from carbon. So from the benzene ring, electrons come out into this attached substitute group. So this is how deactivators are going to promote selectively third carbon atom for further reaction. Now, we can talk about these things in kind of a summary. We will talk about directing effect of groups already attached to benzene ring. What's the meaning of it? Some are going to act as 2,4-directors, some are going to act as 3-directors. Just see, in this benzene ring, we have a D group attached to benzene ring. If this is a deactivator, what happens is third position will be activated. You can see if it undergoes a reaction. It should be ring deactivators. Please correct it. Ring deactivators promote further reaction at third carbon atoms. I can show it in a diagram. See the third carbon atom reaction happens over there. See, I'm going to highlight it. Okay, if there's a ring deactivator, reaction happens on the third carbon atom. On the other hand, if you see another compound where this capital A refers to an activator, activator is giving electrons. When activator gives electrons, I said second and fourth positions are going to get activated. Ring activators promote further reaction at second and fourth carbon atoms by increasing electron density on them. And accordingly, we will get two compounds. First compound is, this should be, again, this should be A. This capital D should be A. In the first compound, a reaction can happen on the second position. Second carbon atom. Or else there can be another compound where, again, this should be A. It is attached to 1. Here, the next reaction happens in the fourth position. Likewise, a clear difference is seen over here between electron activators and electron deactivators. This idea should be there in your mind very well. It is better if you know these things clearly, because in exams, without wasting time, you can quickly find out answers. Usually in some exam papers I have seen, the question introduces to you deactivators and activators, examples are given. But then rather than depending on what is given in the exam paper, if you're ready with this knowledge beforehand, you can very quickly work out the problem. Afterwards, straight away we'll go to a question. Choose a correct product form from the two substances suggested in each reaction. What do I mean by this here? Okay, here we have a compound, methyl benzene. This methyl benzene, if reacted with concentrated nitric acid, concentrated sulfuric acid, 50 to 55 degrees Celsius, you should know that this is nitration. These reaction conditions are going to attach NO2 part into the structure. So my question is this. I suggest you two compounds. From these two compounds, what is the correct product? Okay, while do I get them busy with that, I'll give another question. Here also, tell me which is the actual product. I have given two compounds, but both are not products. Only one product. One more example. Tell me the product. I'll give you 1 minute to find out the answer. I think I have enough time for you. We'll start in the first one. In the first one, we have a CH3 group attached. When you have a CH3 group attached, it's an activator. CH3 group doesn't have lone pairs of electrons on it, but CH3 group has a special property everyone knows in A-level class, positive inductive effect. Because of positive inductive effect, electrons are promoted towards the benzene ring. So what carbon atoms are going to get activated? Electron donors are called 2,4 directors. So where do you think the reaction happens? In the first one, NO2 has gone to third carbon. It is quite possible because CH3 group is promoting second and fourth. So in the second example, we have NO2 getting added on the second carbon atom. Therefore, answer is that. We go to the second one now. In the second one, we are trying to add a chlorine atom. Before you talk about addition of chlorine atom, you should know where it is going to get added. This is NO2. What sort of a compound is NO2? What sort of a group is NO2? It is able to withdraw electrons away from the benzene ring. This is a deactivator. If NO2 is a deactivator, it is going to promote further reactions on the third carbon in the two compounds. Cl has been added into the third carbon in the first one. So answer is there. Got it? We'll go to the third example. In the third example, we have OH. OH has lone pairs of electrons on this oxygen atom. So these electrons get delocalized in the benzene ring and activate fourth position and second position. Where do you think the reaction is happening? Because OH is promoting electrons or donating electrons to benzene ring. Second place and fourth place will be activated. Here, there is a bromine added into the 6 carbon also. A 6 carbon, if I do the naming in the reverse order, then this becomes 2. So this number 6 and number 2 in the benzene ring can be considered as the same thing. So even though we talk about 2,4 directors, we can call it 2,4,6 also. But in our syllabus, this 2,4,6 is not there. 2,4 directors are there. In the third one, what has happened? In the third one, OH, even though it's an electron donor group, the bromine has been shown to have added to the 5th position and 3rd position. This is totally not acceptable. Answer is going to be the first one. Please have a clear idea, because the same knowledge is expected of you in the next question also. See, what are we going to do here? Molecule is there. We are reacting with CH3Cl and aluminum chloride. I'm suggesting 2 products. You choose the correct one. That's another compound. 2 products are there. You suggest the correct answer. 1 minute again to find out the answer. Shall we see? Guys, now see here in the first compound, there are 2 groups attached. First group is NO2. Second group is CH3. What do they do? NO2 is an electron withdrawing group. CH3 is giving electrons into the benzene. So I'll talk about CH3 first. CH3 is promoting further additions on the 2nd place and 4th place. Therefore, answer is going to be the second one. Likewise, in the second one, on the left-hand side, we have OH group. On the right-hand side, we have NH2 group. What do? They both promote electron, they both increase electron density on 2nd and 4th carbon relative to them. Taking that into consideration, if you try to find out the answer, we can see because of OH, 1 CH3 comes here, 1 CH3 comes here. Because it's NH2, 1 CH3 goes over there, 1 CH3 comes over here. Likewise, answer is going to be the second one. The electron donor effect of both the groups, both OH and NH2, have influenced the benzene ring to get CH3 groups to all the available 4 carbon atoms, which can react further. Hope you get the answer, or at least you get what I try to give to you. I think I have one more question of this nature. This is simple because we have learned a few things earlier. Can I give you 1 more minute to work out the answers yourself first? Shall we start the discussion now? What do you think is the answer? First one or the second one? You have to think like this. See this CH3? CH3 is an electron donor group. Because it's an electron donor group, the two carbon atoms on either side of the benzene ring next to CH3 will get bromine. One bromine will come over here, another bromine will come over here. So it is seen in both the compounds. Now I go to NH2. NH2 will activate benzene compared to the position of NH2. The carbon atom on the left-hand side will react. And the opposite side, nothing will happen to this carbon atom. So the answer is going to be the first one. You try to compare the relative position of carbon atoms, which are going to be activated, and further reactions are allowed. Second one. In the second one, we have NO2 and there's an aldehyde group. They both are electron withdrawing groups. So we have to find out, compared to the position of this alkyl group or aldehyde group, what are 3 and 4? 3 and 4. This is 3 and 5. This is 3, this is 5. Or this is 3, this is 5. So we consider this place for the reaction to occur because the other side has already reacted. So this CHO is promoting addition of chlorine, giving the final answer in that manner. Please try to compare the ability of NO2 and CHO to attract electrons away from the benzene ring and activate areas selectively. If you do this exercise several times, you will be able to, through proper scrutinizing, you can learn actually how selectively certain positions are going to be activated due to groups attached to benzene ring. Well, we'll take 1 or 2 questions, not of the same pattern. Okay, look at this. There are 1, 2, 3, 4, 5. This is a reaction where methyl benzene, at the very beginning we have methyl benzene, is going to produce benzocaine. 4 reactions are there. Your work is now within 2 minutes, so 1 minute, I think is easy. Find out the reaction conditions and reagents needed for these 4 reactions, please. Time starts now, just 1 minute. Are we ready for the answers now? Check your answers with the answers I'm going to bring into the screen. See the first reaction? Addition of NO2. It is concentrated H2SO4, concentrated HNO3, 50 to 55. Second one, side chain oxidation, KMNO4, alkaline medium, heat, then acid. Third one, reduction, thin and concentrated HCl. Fourth one is an esterification reaction. For that, the top part of this molecule over here, COOH, has gone to an ester group. For that, we have to have ethanol added. So we have added ethanol concentrated sulfuric acid, and heat is also needed. Tell me nothing but that you have understood this. Shall we go to another question? Okay, here I have given you a reactant conditions with reagents. I want you to find out the product. Second reaction. Conditions are given, reactants are given, get me the product. A third reaction. And a fourth reaction. Don't take much time. Again, argue 1 minute. Okay, enough. In the first one, we have UV radiation and chlorine gas. This is the condition exactly we use for free radical substitution reactions of alkanes. A benzene will not react with this condition. The alkyl group attached to benzene ring CH2CH3 will react with UV and chlorine, producing CHCl-CH3. If you want, we can take this chlorine to the cornermost position also. You can produce this as an answer. That's the first one. Shall we go to the second one? See. This is a halogenoalkane part. When halogenoalkane part reacts with sodium hydroxide, alcoholic medium, heat and reflux, and elimination reaction occurs. This is from AS chemistry. One double bond comes into this compound. Shall we go to the third one? In third one, we have KMnO4 alkaline. We are heated, and then we have red acid. This is side chain oxidation. If there's an alkyl group, this alkyl group goes to carboxylic acid, and that's all happening here. CH2CH3 has gone to COOH, carboxylic acid. Now we go to the last one. We have CH2CH3 group attached to benzene ring. Now the reactants we are using, reagents and conditions are chlorine and aluminum chloride. This chlorine and aluminum chloride combination of reactants is to add a chlorine atom into the benzene ring. This alkyl group promotes electrons in the second and fourth place. So we may get two products in this. This is a chlorine atom attached to the second position of the benzene ring. And in the other one, that chlorine has been attached to the fourth carbon compared to the position of CH2CH3. Okay, guys, now here I'm trying to help you out how to find out the products according to different reagent conditions, combinations. This knowledge is very much necessary for you to get a good grading in your A2 paper. You are expected to read notes and watch this video several times if you like, until you are confident with the content. Okay, that's it for now, guys. Thank you for learning with EasyChem. Thanks a lot.